Good morning to all. Next unit is classification of circuit breakers. So in this unit, we are going to see different types of circuit breakers, and we are going to learn their construction, working, what all their advantages are there and disadvantages are there. So circuit breakers can be classified based on the type of current that is given to the circuit breaker. The current that is given to the circuit breaker, it can be AC current or DC current. Okay, so you can see here. So depending on the type of current that is given to the circuit breaker, so circuit breaker can be classified as DC circuit breaker or AC circuit breaker. We can see an DC circuit breaker image. You can see an AC circuit breaker image. Then further, circuit breakers can be classified based on the rated voltage. Okay, so if the circuit breakers rating is below 1000 volts, okay, so the circuit breakers below rated voltage of 1000 volts, they are classified as low voltage circuit breakers. So you can see the images of the low voltage circuit breakers. Now if the circuit breaker uh, voltage rating is between 1000 volts to 52 kilovolts, then such circuit breakers come under medium voltage circuit breakers. Okay, they are classified as medium voltage circuit breakers. You can see the images of medium voltage circuit breakers. Okay, next, if the circuit breakers with rated voltage is in between 66 kilovolts to 220 kilovolts, okay, if the voltage rating of the circuit breaker is in between 66 kilovolts to 220 kilovolts, those circuit breakers are classified as high voltage circuit breakers. Okay, and further, if the voltage rating of the circuit breaker is in between 300 kilovolts to 765 kilovolts, okay, they are classified as extra high voltage circuit breakers. And if the voltage rating of the circuit breaker is above 765 kilovolts, then such circuit breakers are classified as ultra high voltage circuit breakers. So based on the rating, voltage rating of the circuit breakers can be classified as low voltage circuit breakers, medium voltage circuit breakers, high voltage circuit breakers, extra high voltage circuit breakers, and ultra high voltage circuit breakers. Further, circuit breakers can be classified as indoor type circuit breakers and outdoor type circuit breakers. So you can see an image of indoor circuit breaker, and this is an outdoor circuit breaker. Now, depending on the arc extinguishing medium, further circuit breakers can be classified as oil circuit breakers, air circuit breakers, SF6 circuit breakers, and vacuum circuit breakers. Okay, so we have already discussed uh, about the circuit breaker contacts. Circuit breaker contacts are always placed in an arc extinguishing medium. Okay, so the arc extinguishing medium, it can be oil, air, SF6 or vacuum. So we let us see some images here. You can see this is an oil circuit breaker, and this is an air blast circuit breaker. This is air blast circuit breaker. This is one type of air circuit breaker. Okay, different types of air circuit breakers are there. This is one type, that is air blast circuit breaker. So this is SF6 circuit breaker, and this is an vacuum circuit breaker. So let us discuss about all these types of circuit breakers based on the medium, arc quenching medium. Okay, they are classified. Okay, so in our syllabus, based on the arc quenching medium, the classification of circuit breakers is there. So let us start with oil circuit breaker. So you can see an oil circuit breaker here. Okay, so the oil in this circuit breakers, the circuit breaker contacts are placed in an oil. Okay, so within the circuit breaker chamber, the oil is filled. So the oil which is used in the circuit breaker, okay, So the circuit breaker contacts are surrounded by some oil. That oil is nothing but the mineral oil. Okay, so why we are using mineral oil? The reason behind that is mineral oil has better insulating properties than air. Okay, and oil has a good cooling property also. Okay, so in a circuit breaker, when arc is formed, or that is when arc is struck between the contacts, it decomposes oil into gases because of the heat produced by the arc. What will happen is the oil will be decomposed into gases. Okay, hence arc energy is absorbed in decomposing the oil. Okay, so these gases prevent restriking of the arc after the current reaches 0 point of the cycle. Okay, so in oil circuit breakers, when circuit breaker contacts open, when the contacts are surrounded by a mineral oil, when the circuit breaker contacts open, what will happen is arc is struck between the contacts, and this arc, when it comes in contact with the oil, when the circuit breaker contacts open, what will happen, it will decompose the oil surrounding it, and the gases which are evaluated due to the decomposition of the oil, what will happen is these gases will prevent restriking of the arc after the current reaches 0 point of the cycle. There are some disadvantages for the oil circuit breaker. The disadvantages are it is inflammable and may pose a fire hazard, and it include the possibility of forming explosive mixture with air and the production of carbon particles in the oil due to heating, which reduces its dielectric strength. Okay, so because of these disadvantages, oil circuit breakers are not suitable for heavy current interruption at low voltages due to carbonization of the oil. Okay, so these are the disadvantages because of it, this oil circuit breakers. Okay, so means the circuit breakers in which arc quenching medium is oil, mineral oil, is not suitable for heavy current interruption at low voltages. So the oil circuit breakers can be classified as plain break oil circuit breaker, arc control oil circuit breaker, and minimum oil circuit breaker. So you can even call minimum oil circuit breaker as low oil circuit breaker, but in general it is called as minimum oil circuit breaker. Okay, so we will discuss one by one about these circuit breakers construction and operation. Let us start with plain break oil circuit breaker. Okay, so this is a plain break oil circuit breaker. So the construction of this plain break oil circuit breaker is very simple. It consists of current carrying contacts immersed in an oil known as transformer oil. You can see here. So this dotted line, whatever you can see in this within this tank, this dotted lines represents the transformer oil. Okay. So this transformer oil and this moving contact and the fixed contacts are, of course, this moving contact and fixed contacts are immersed in this transformer oil, and this transformer oil is filled in a strong, weather tight, and earthed metallic tank. Okay, so a metal tank which is strong and weather tight is taken in that transformer oil is filled. Okay, so of course it is not fully filled by the transformer oil. There is an oil, there will be always some oil level will be maintained. It is transformer oil is filled in this metal tank in such a way that the contacts are fully immersed within the oil. Okay, and some air cushion must be maintained at the top of the tank. What is the need of air cushion, we will discuss. Okay, so here this transformer oil is acting as both extinguishing medium as well as insulator. Okay, and you can call this plain break oil circuit breaker also as double break plain oil circuit breaker. Okay, why we are calling it as double break plain oil circuit breaker. The reason behind is, if you observe in this image, there are two moving contacts. This is one moving contact, this is also one moving contact. This is a fixed contact, this is a fixed contact. Okay, so these two are the fixed contacts, these two are the moving contacts. So two arcs will struck here. Okay, if these contacts move apart. So in this image, it seems these two contacts are separated, but under normal operating condition, the moving contact will be in contact with the fixed contact. Okay, so under normal operating condition, moving contact will be in contact with the fixed contact. There will not be any gap between these two contacts. Okay, there will not be any gap between these two contacts. They will be in contact with each other. Okay, so if fault occurs, or under normal operating condition also, if you want to use this circuit breaker as a switch, if the moving contact is moved away from the fixed contact, what will happen is a severe arc will struck between these two contacts. Okay, as the moving contact is moving further away from the fixed contact, the length of the arc will increase. Okay, and due to the heat produced by the arc, okay, it decomposes the oil which is in contact with the arc into gases. Okay, so this gaseous medium which is surrounding the arc, okay, so it will fully cover the arc. Okay, so the oil, as soon as gaseous medium is formed, okay, it will fully cover the surrounding of the arc. Okay, so the gaseous medium surrounding the arc will extinguish the arc at some natural current 0. Okay, and the gas obtained from the oil is mainly hydrogen. Volume of the gas produced will be around 1000 times to that of the oil decomposed. Due to this volume, oil is pushed away from the arc and gaseous medium surrounds the arc. Okay, because of this volume only, gaseous medium will push away the oil away from the arc. Okay, so there will be a turbulent motion of the oil due to the gases passing through it. Okay, so a large gaseous pressure is developed because a large amount of energy is dissipated within the tank. Okay, as the arc extinguishes, a large amount of energy is dissipated within the tank. Therefore, the tank of the circuit breaker must be made to withstand such a large pressure. Okay, so it must be made strong to withstand such a large pressure. So when gas is formed around the arc, the oil is displaced. To accommodate the displaced oil, an arc cushion between the oil surface and the tank is formed. Okay, so this is it. So when gas is formed within the arc, you can see in this image. So when gas is formed within the arc, around the arc actually, so when gas is formed around the arc, the oil is displaced. Okay, to accommodate the displaced oil, an air cushion, okay, to accommodate the displaced oil, an air cushion between the oil surface and the tank is formed. So this air cushion will also absorb the mechanical shock produced due to upward oil movement. Okay, and a vent is provided, okay, at the top of this tank. Okay, so for gas outlet. Okay, and a sufficient level of oil above the contact is required to provide substantial oil pressure at the arc. So double breaker consists of two brakes. These two brakes. Okay, it consists of two brakes. These two brakes will be in series to each other. Okay, the two brakes in series will provide rapid arc lengthening within the need for a specially fast moving contact speed, and the total gap distance at the end of the stroke can conveniently be made ample. Okay, in practical point of view, the speed of the brake should be as high as possible because a certain brake distance has to be reached before interruption is likely to occur. Okay, so the sufficient distance must be reached before the arc extinguishes between the contacts. Okay, and sooner it is achieved, smaller the energy released in the breaker and lesser mechanical strong breaker has to be designed. Okay, so as soon as possible the moving contact should be moved afar from the fixed contact in order to avoid interruption of the arc before natural current zero. Okay, so the main drawback of double break plain oil circuit breaker is that for unequal voltage distribution, okay, across the breakers. Okay, so the main drawback is there will be unequal voltage distribution across these two breakers, or we will call it as breaks. Thus, unequal sharing of total interrupting duty is caused. Okay, so let us consider uh, this image. Let us consider this image. So you can see these two are the fixed contacts. These two are the moving contacts. Okay. So let us assume some short circuit fault has occurred here. Okay. And this is our plain break oil circuit breaker. Okay, and this is the supply that is given to this one of the, this is a conductor, this line is the conductor line, this is also the conductor line, because you might have already seen here, I have shown here, this is the conductor line, these are the bushings which are coming out from this transform, I'm sorry, circuit breaker tank. Okay, so this figure here illustrates the capacitance between contacts. So let us assume the capacitance between moving contact and fixed contacts is C1, and the capacitance between the moving contact and the earth is C2. Okay, in between moving contact and earth is C2, in between moving and fixed contact is C1. Okay, so voltage across first contact, let us assume it as V1, voltage across second contact, this is the first contact, this is the second contact, so voltage across first contact C1, voltage across second contact is C2. Okay, and let us assume some short circuit has occurred here, so fault current is some I. So from the equivalent circuit, V1 is equal to I by omega C1. Okay, from this equivalence, V1 is equal to I by omega C1, and V2 is equal to I by omega C1 plus C2 from this equivalent circuit. Okay, now we have got some voltage equations from the equivalent circuit. So we can take the ratio of V1 by V2. So V1 by V2 is I by omega C1 into actually I by omega C1 by I by omega C1 plus C2. So you can rewrite it as I by omega C1 into omega C1 plus C2 by I. Okay, so I will be cancelled. Leftover is omega C1 plus C2 by omega C1. So omega will be cancelled. So V1 by V2 is omega, C1 plus C2 by C1. So this is what we have got. Let us substitute some values here. Let us assume some values for C1 and C2. Let us assume C1 is 8 picofarad and C2 is 16 picofarad. Okay, so if we substitute C1 and C2 values in this above formula, V1 by V2 is equal to C1 plus C2 by C1. So you will get 8 plus 16 by 8. So you will get 24 by 8, that is equal to 3. So V1 by V2 is equal to 3. Okay. But from figure, from this equivalent circuit, what is V? V is equal to V1 plus V2. Okay. V is equal to V1 plus V2. So that's what I have written. V1 plus V2 is nothing but V. V1 is what? 3 times of V2. V1 is 3 times of V2. That means that when V1 is 3 times of V2 and when V1 plus V2 is equal to V. Okay. So if you can substitute instead of V1, you can write 3V2. So 4V2 it will be. V is 4V2. So we can say V2 is 25% of the system voltage and V1 is 75% of the system voltage. Okay, V2 is 25% of system voltage and V1 is 70% of the system voltage. So to equalize the means the voltage distribution across these two, okay, voltage distribution across these two breaks is not equal. Okay, so voltage distribution actually should be equal. So to equalize the voltage distribution across the breaks, a non-linear resistor must be connected across each break. Okay, you know the property of a non-linear resistor. We have discussed many a times about the non-linear resistor in the previous classes. Okay, so to equalize the voltage distribution across the breaks, nonlinear resistors are connected across each break. Okay, so plain break oil circuit breakers are employed for breaking of low currents at comparatively low voltages. Okay, so these plain break oil circuit breakers are used for interruption of low currents at comparatively low voltages. Okay, they are used in low voltage DC circuits as well as low voltage AC distribution circuits. Okay, so this is about plain break oil circuit breaker. So there are some advantages for this. The oil has high dielectric strength, and mineral oil that we are going to use here has higher dielectric strength, and it provides insulation between the contact after the arc has been extinguished. As soon as arc is extinguished, okay, so the oil the contact the in between the contacts, the oil will rush in between the contacts, okay, and it acts as the insulating medium between the contacts. The oil used in this circuit breaker provides a small clearance between the contact and the earth component, okay, and hydrogen gas is formed in the tank, which has a high diffusion rate and good cooling property. So that is the advantage of this plain break oil circuit breaker. Disadvantages we have already discussed. Okay, so mineral oil used in this oil circuit breaker is inflammable and can cause fire hazards. Okay, so it can form a explosive mixture with air. So due to decomposition of oil in the air, carbon particles are produced here, okay, which pollutes the oil, and hence dielectric strength of the oil will decrease due to carbonization. Okay, due to carbonization, dielectric strength of the oil will reduce. These are the advantages and disadvantages of plain break oil circuit breaker